Earth, Moon, and Sun. This is Astronomy, Lesson 4, Phases and Eclipses. What causes the moon phases? Have you ever been kept awake by a bright moonlight? The light streaming through your window actually comes from the sun. The moon does not shine on its own. Instead, it reflects light from the sun. When the moon is full, this light may be bright enough to read by. But at other times, the moon is just a thin crescent in the sky. The different shapes of the moon you see from Earth are called the phases. Phases are caused by the motions of the moon and the Earth. Motions of our moon. When you look up at the moon, you may see what looks like a face. What you are really seeing is a pattern of light-colored and dark-colored areas on the moon's surface. Oddly, this pattern never seems to move. The same side of the moon, the near side, always faces Earth. The far side of the moon always faces away from Earth. The answer to this has to do with the motions of the moon. Like Earth, the moon moves through space in two ways. The moon revolves around Earth, and it also rotates on its own axis. The moon rotates once on its axis in the same time it takes to revolve once around the Earth. Because of this, a day on the moon is the same length as a month on Earth. For this reason, the same side of the moon always faces Earth. As the moon orbits Earth, the relative position of the moon, Earth, and Sun change. The changing relative positions of the moon, Earth, and Sun cause the phases of the moon. So if we're looking at this image here, if this side is the face of the moon, as the moon rotates and revolves around Earth, this happens at the same rate. So one side of the moon constantly faces toward the Earth. And this side we would not be able to see the face of the moon. So as the moon revolves around the Earth, it also rotates at the same rate, leaving one side of the moon constantly facing the Earth. The phases of the moon. Half of the moon is almost always lit by sunlight, but since the moon orbits Earth, you see the moon from different angles. The phases of the moon you see depend on how much of the sunlit side of the moon faces Earth. During the new moon, the side of the moon facing Earth is not lit. As the moon revolves around Earth, you see more of the lit side of the moon, until you see all of the lit side. As the month continues, you see less of the lit side. As you can see by the images here, it takes about 29.5 days after the last new moon in order for us to get a new moon. So approximately the amount of time it takes for us to go through the phases equals about the same as a month. So we can see here where as the moon is away from the Earth, we have a full moon because we can see the entire lit side of the moon. We continue to go through that lunar month and we see less and less of the lit side of the moon. We go into waning gibbous, third quarter, waning crescent. The new moon is when we have the the dark side of the moon, or the shadowed side of the moon facing Earth, so we don't see a moon. And then as we get into the waxing, the moon is actually progressively getting brighter and brighter each night. Here's another picture to show the same representation, starting with new moon all the way to full moon, and then going through our waning periods where we lose sunlight. This picture shows the moon as it goes through each one of those phases. So we'll play that again. So right now we are waxing. Now we've got to full moon. Now we're waning, third quarter moon, all the way back to the new moon. This is kind of the same image, same video. I'm just going to walk through each one of those phases of the moon as well. So we start with new moon, going through the waxing, now the waning, until the moon reaches back to new moon. Again, starting with new moon, we then go to waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, waning crescent, and the new moon. What are eclipses? The moon's orbit around Earth is slightly tilted with respect to Earth's orbit around the sun. As a result, the moon travels above and below Earth's orbit. But on rare occasions, Earth, the moon, and the sun line up. When an object in space comes between the sun and a third object, it casts a shadow on that object, causing an eclipse. There are two types of eclipses that we see here on Earth: a solar eclipse and a lunar eclipse. The words solar and lunar come from the Latin words for sun and moon. So solar eclipse. During a new moon, the moon lies between Earth and the sun. A solar eclipse occurs when the moon passes directly between Earth and the sun, blocking sunlight from Earth. The moon's shadow then hits Earth. A total solar eclipse occurs when the very darkest part of the moon's shadow, the umbra, passes directly over top of the area where we live. We can see how the umbra strikes Earth in this picture. Within the umbra, the sun's light is completely blocked. Only people within the umbra experience a total solar eclipse. During a total solar eclipse, the sky grows as dark as the night. The air gets cool and the sky becomes an eerie color. You can see the stars and the solar corona, which is the faint outermost layer of the sun's atmosphere. A partial solar eclipse does occur as well. During a partial solar eclipse, the moon casts another part of its shadow that is less dark than the umbra. The larger part of the shadow is called the penumbra. In the penumbra part of the sun, it is visible from different parts of the planet. So outside of the umbra, where the penumbra is, we get a not quite as dark shadow cast on the planet. During a solar eclipse, people in the penumbra see only a partial eclipse. This picture represents what you would see if there was an eclipse. And this would be an example of a full solar eclipse. So the penumbra would be the area of the shadow that is not quite as dark. The umbra is the darkest part of the shadow, and it would be cast on the surface. And we would see much the same as what we see for some of the phases of the moon, we would see where the sun's light would slowly be blocked out more and more until the moon was completely in front of the sun, and then the moon would slowly move out of the way. Here's a video that shows the actual shadow as it would be cast from the moon on the Earth. You can see that large shadow passing over. Play that again. Large shadows passing over. Here's another video being a little bit more specific about what the shadow would look like without the moon in the way. You can see the shadow come in. That dark point in there would be the umbra. And then this is what we would see from Earth. The moon would slowly move into place in front of the sun. Eventually the moon would completely block out the sun. We'd see the outermost atmosphere of the sun at that point, and the moon would slowly make its way off and out of the way of the sun's light. A lunar eclipse. Lunar eclipse is a little bit different from a solar eclipse. During most months, the moon moves near Earth's shadow, but not quite into it. A lunar eclipse occurs at a full moon when Earth is directly between the moon and the sun. During a lunar eclipse, Earth blocks sunlight from reaching the moon. Lunar eclipses occur only when there is a full moon because the moon is closest to Earth's shadow at that time. A total lunar eclipse can occur, much like a total solar eclipse. Like the moon's shadow, in a solar eclipse, Earth's shadow has an umbra and a penumbra. When the moon is in Earth's umbra, you see a total lunar eclipse. Unlike a total solar eclipse, a total lunar eclipse can be seen anywhere on Earth that the moon is visible. So you are more likely to see a total lunar eclipse than a total solar eclipse. Partial lunar eclipses can occur as well. For most lunar eclipses, Earth, the moon, and the sun are not quite in line, and only a partial lunar eclipse results. A particular lunar eclipse occurs when the moon passes partially into the umbra of Earth's shadow. The edge of the umbra appears blurry, and you can watch as it passes the moon for 2 or 3 hours. So here's a video of this would be an actual lunar eclipse, a full lunar eclipse. So the moon passes into Earth's umbra. Usually there's a reddening color of the moon's light, the light that's reflected off the moon. Alright, I've got a picture project for you. Looking at this picture, the season. In order to determine the season, we look at Earth's axis. In this case, the northern hemisphere is directly towards the sun. The southern hemisphere is facing away from the sun. So the season, based on this picture, would be summer for the northern hemisphere. The moon phase, in this case, because we would be directly looking at the moon, and the shadow would be cast towards Earth, this would give us a new moon. And then finally, what type of eclipse would we get in this case? In this case, we would have a solar eclipse occurring because the moon would block out the light from the sun. It would get in the way of the sun. So we would end up with a solar eclipse. Using the diagram that we see here as a model, I want you to draw the arrangement of Earth, the moon, and the sun during a total lunar eclipse in December. So draw the arrangement of Earth, the moon, and the sun during a total lunar eclipse in December. Use the picture as a model.